Welcome to The Explainer. Today, we're cracking open a cosmic case file on one of the most absolutely stunning objects in the night sky, the Iris Nebula. Now, this beauty is located about 1,300 light-years away in the constellation Cepheus, and trust me, it is so much more than just a pretty picture.
Okay, let's just take a second to look at this. I mean, it really does look like a delicate flower unfurling its petals out there in the void, doesn't it? It's all lit up by that super bright star right at its heart. Now, this is what's called a reflection nebula. You can think of it as a giant cosmic mirror. The light from the star is just bouncing off all those surrounding clouds of dust, and that's what creates this incredible glow.
But here is where the plot thickens. This nebula, it turns out, is way more than just a pretty face. It's more like a giant, cosmic-scale chemistry lab. And for years, astronomers have been playing detective, trying to piece together the clues to figure out what kind of exotic molecules are being cooked up inside.
So, our investigation really kicks off with the first big clue that something weird was going on here. And that clue is a mysterious phenomenon they call extended red emission, or ERE for short. You know, this glow was a real head-scratcher. The process behind it is called photoluminescence. Think of it kind of like a glow-in-the-dark sticker. It soaks up energy from light and then slowly releases it as a glow. But here's the problem. When astronomers did the math, there just weren't enough high-energy photons or little packets of light coming from that central star to explain all the red light they were seeing. Something just wasn't adding up.
And this is where the solution gets really clever. It's not a simple one-and-done process. Instead, scientists figured out it's actually a two-step deal. First, a rare, super high-energy UV photon acts as a kind of initiator. It zaps a molecule and creates this special carrier molecule. You can think of this carrier as being primed and ready to go, and then this primed carrier can be lit up over and over and over again by the much more common, lower-energy photons. And that, right there, perfectly explains all that extra red glow.
So this new theory pointed the finger directly at a specific family of molecules as the prime suspects. They're called polycyclic aromatic hydrocarbons, or PAHs. Now these are carbon-based molecules, and you find them pretty much everywhere in the universe. I mean, you can even find them in things like soot and car exhaust right here on Earth. They're incredibly common and surprisingly tough.
Okay, so with a suspect in mind, it was time to profile them. To really crack this case, scientists had to get to know these PAHs inside and out. So PAHs are basically these microscopic flakes of soot, and they come in a huge variety of different shapes and sizes. To solve this mystery, it wasn't enough for scientists to just know that PAHs were there. They needed to know exactly how big these molecules were, and, this is the crucial part, where exactly they were hiding inside the nebula. They needed a map. And to get that map, a team used the SOFIA Airborne Observatory, which is, and this is so cool, literally a massive telescope mounted inside a 747 jumbo jet. By flying high above most of Earth's atmosphere, they created this incredible-sized map you see on the right. And what it reveals? Well, it's a dramatic story of life and death on a molecular scale. Now look at those bright filaments on the left image. That's the edge of the giant molecular cloud, and that's where all the action is happening.
Now here's where the data really starts to tell the story. This graph shows us what's happening as we move out from the central star. See that dotted line? That marks the surface of the cloud we just saw. And if you follow the red line, which tracks the average size of the PAHs, you see something fascinating. Right at that surface, the size of the PAHs hits rock bottom. They're tiny here, made of only about 50 carbon atoms.
So, what's going on? Well, at the surface of the cloud, small PAHs are essentially being born. They're getting blasted off of larger dust grains. This is also the exact same spot where that mysterious red glow is at its absolute brightest. But this surface is an incredibly violent place. The radiation from that central star is like a cosmic blowtorch, and it's just demolishing the smallest, most fragile PAHs almost as soon as they form. Only the biggest, toughest PAHs, the ones with 70 or more carbon atoms, can actually survive that onslaught and make it deeper into the nebula.
But, just when it seemed like one part of the case was all wrapped up, other clues started to emerge, and they showed that the story was even more complex than anyone had realized. The Iris Nebula wasn't done giving up its secrets.
Using the Spitzer Space Telescope, astronomers found a whole new set of strange signals in the nebula's light signatures that didn't match any known molecule. It's like finding a completely new set of fingerprints at a crime scene. You know they're a huge clue, but you have no idea who they belong to.
And this is where things get really wild. The investigation took a sharp turn and started focusing on another exotic carbon molecule. One of the most interesting structures in all of chemistry, actually. It's called the C60 fullerene. It's shaped just like a microscopic soccer ball, so of course, it has a fantastic nickname, the buckyball.
Now, here's the crazy part. The first time astronomers looked for buckyballs in the Iris Nebula, way back in 1999, they came up totally empty. It looked like a complete dead end. But the case was far from closed. Newer research in computer models are now suggesting something incredible, that those big, tough PAHs we saw surviving deep inside the nebula might actually be getting transformed into buckyballs by all that intense starlight. Just like that, a cold case went red hot.
So, after examining all this evidence, what's the final verdict? What can we really conclude from the cosmic case file of the Iris Nebula?
Well, let's lay all the clues out on the table. We have the red glow, which proves that this isn't just reflected light. There's active chemistry going on. We have the PAH map, which reveals this constant, brutal cycle of creation and destruction. And then we have those unidentified signals, telling us that the chemistry here is even richer and more complex than we could have possibly imagined.
The verdict is in. The Iris Nebula is not some static, peaceful flower floating in space. It is a bustling, active, and sometimes violent molecular factory. In this factory, starlight is the engine that both forges and destroys the very carbon-based molecules that are the fundamental building blocks for planets and, maybe one day, for life itself.
And that's why this all matters so much. Studying places like the Iris Nebula isn't just about solving some distant cosmic puzzle. It's about looking back at our own origins. The very atoms that make up our planet, that make up you and me, were cooked up in places just like this one. These nebula are the crucibles where the raw materials for future stars, future planets, and maybe even future life are being processed right now as we speak.
It really makes you look up at the night sky a little differently, doesn't it? If all of this complex, intricate chemistry is happening in just one glowing patch of space, imagine what other incredible cosmic factories are out there right now, churning out the building blocks of the next generation of the universe. What other amazing secrets are just waiting for us to find them, hiding in plain sight up there between the stars?